Hey, this is Joe Mancuso. Today I'll be presenting the Masonite Python web framework. Masonite is a fairly new Python web framework, just shy of being 1 year old. And although it's pretty young, it still has some really advanced features, including things like template caching, WebSocket broadcasting support, Amazon S3 uploading support, Mailgun, email support, easy database seeding, command line application scaffolding, built-in queue support for running jobs asynchronously or through RabbitMQ or something. If you really love Django, then I think you'll really love Masonite. Most of the feedback I get is that Masonite makes things happen really quickly, so it's easy to get your application up and deployed quickly. I'll demonstrate some of those features here with Masonite that really set it apart from other Python web frameworks. So since this is really a Keynote style video, I won't really go in depth on how to install Masonite right now. You can read that over on the documentation. I really just want to dive in onto the features and how you as a developer can really use Masonite. So right off the bat, this is a basic Masonite application. So firstly, I just want to explain these craft commands. So Masonite comes with a CLI tool called Craft. It has some of these commands built in that can help you interact with Masonite a little bit better. So for example, you might be able to create an authentication system, which will create views and controllers and routes for you. You can create controllers, you can enter your application into a maintenance state, you can generate secret keys, you can run migrations and all that fun stuff. So here we have a craft serve, which is right here, similar to how Django runs their development server. So for example, if we say craft serve, this will serve the application. So we can open it and we could see our application running. We could also do a -r flag, which will run it in sort of a reloading mode. So when we make changes, it'll refresh. So we're going to keep it in that state for now. So if we go ahead and open our routes. So in Masonite, these are routes. So you have the get routes, and you can have some post routes as well, as you can see right here. So these are some basic routes that I have. This is what I'll be using to demonstrate the framework. So the setup is really simple. It's what route do you want to be hit, and what controller do you want to perform that action. So if we open up that controller here, we can see we have that show method that we had before. So controller at show, and we can open that here, controller at show. So before we get into queues though, I just want to demonstrate the craft command a little more and just show how powerful it can be. So if we go back to our browser, you can see that we don't really have any sort of authentication system. I know Django has the admin panel, but there's no place to log in or register. So Craft makes that, or Masonite rather, makes that really simple by just running a craft auth, and now we scaffolded our application. So now if we run that server again, you can see we actually have a full authentication system. So if we try to log in here, we'll probably get an error, right? So we didn't run our migrations or anything. So let's go ahead, and here's our table actually. So we don't have anything here. And if we run our migrations by running craft migrate, that'll migrate the users table. And if we open up that, we don't have any users. So Masonite out of the box wants to be really quick with development. So we'll just create 50 users by running craft seed run. So now our database is seeded, and we have 50 users now. All of the passwords are secret, the string secret, and they're decrypted. So let's go ahead and let's actually try to just log in as them. Let's just run our server again. And log in, so their email, and it is secret. And there you go. We have a authentication system. You can obviously create different seeds, but that one is provided for you out of the box on your user model, which your user model is located in app, and your user model's right here. So we have a basic user model out of the box. And we'll go over models a little more in a little bit. So Masonite has a lot of the same features that a framework like Django has, or even Flask, where a lot of the frameworks point you in the right goal, but they have different ways of doing things. So everything has a response, request, an ORM. So what I actually want to explore next is queuing. So this is actually a pretty cool feature where you could actually take a job, right? So this hello world job, let's open that up. And it's a simple job that just prints hello world, and that's it. So going back to our queue controller, we see that we're taking this queue and we have it inside this parameter list. And then we're going to take the queue and then we're going to push it on this job onto the queue. Now let's take actually a minute and talk about this right here, because although it probably looks small, this is actually what makes up Masonite. So Masonite has what's called a service container or an IOC container, where all the application dependencies are loaded into the container, and you're able to actually resolve dependencies as you need them into your controllers. If you're familiar with Laravel, this is how Laravel does it. So what we're basically doing is we're quote unquote type hinting that we need this queue class, which we import up here. So we need this queue class, and we're going to store it into a variable called queue, and then we're going to use the class itself. So when this object gets called, Masonite is going to say, okay, you need this queue class right here. Let me go fetch it for you. This is really powerful because you're able to swap out your dependencies all throughout your application in a centralized spot. So it allows you to very, very loosely decouple your application code to your dependencies. That's something that not other Python web frameworks have. And I think that alone right there is what really separates Masonite from the rest. It might seem confusing and you might not understand it, but once you start using it, you'll slowly understand the power of it. So let's go ahead and actually just hit this queue route. So if we go back here and we say /q, you know how this is queued. And if we go back to our terminal, we see that it printed hello world, right? And it did that asynchronously. So if we go to our .env file, Masonite uses this .env file to manage environment variables for you out of the box, which is really cool. So we have this queue driver is an asynchronous queue driver. You could do an asynchronous or an AMQP queue driver, which talks to like a service like RabbitMQ. So going back to our queue controller, printing hello world probably isn't good to push on a queue, but you could push something like this email onto a queue, which we'll do down here. So what's actually even cooler out of the box is that if we actually change this to AMQP, and we'll have to shut our server down, and we can go to this terminal right here, and we can run craft queue work, which we should get an error. Okay, so we actually don't have this Pika library. So let's go ahead and run it. And go ahead again, and we might get another error. No, it's okay. So our RabbitMQ server is working. And let's just do that. Okay, so once we come here, let's start our server back up. And if we go here now, we see that we didn't get anything here, but if we go to our worker, we actually got the hello world, right? Because this is now processing RabbitMQ jobs. So this is actually processing RabbitMQ jobs, right? So if we go to our terminal, you can see that our broker is started, right? RabbitMQ server is running. So Masonite has really excellent queue support out of the box. So if you want to just run some pretty long things like maybe some SQL queries that involve some time-consuming updating, you can run those in queues. And in production, you can start up a RabbitMQ server and just let that run its course, and then just let that process jobs. So let's demonstrate that a little more. So if we go back to our queue controller, we can see that we have an email here, /email. Let's go ahead and open that. And let's see how long it sort of takes to run. So you see it sort of thinks for a little bit. Right, it's short because it's only sending a small email, but if we go here, we now have these 3 emails that we just sent. All right, so now if we come back here, and let's just get rid of this driver here. So it'll use the default driver. And we go here and we say queue email. You can see that's faster, right? So now it's queuing. It's still sending, but it's going through this queue right here, right? So email sent. If we don't want to use a worker at all, we could specify the driver specifically. So we could shut down this. We have no queue worker anymore. We can even shut down our application here. Now this will still work, right? Because now it's running this job asynchronously. So let's go ahead and try that again. Let's delete all these emails. And if we run it, still see it was pretty fast, and it sent an email still, right? And this says from the queue. This is a very, very basic way of sending mail. You could also do things like send templates and pass around variables and all that fun stuff. You can read more of that in the documentation. The documentation is pretty extensive, actually. So next, let's actually talk a little bit about uploading. So if we go to our upload controller, so we have a couple of routes here, right? So let's go ahead and hit that upload route. So we have a simple form, if you call it a form. We could choose a file here, and we can submit it, and it uploaded. And it uploaded to our storage uploads, and we have this nice picture of Pikachu here. Pretty simple, but what's even more cool is that if you put your S3 credentials in your .env file, which I put way on the bottom so nobody sees, but we can actually call which driver we want. So we want the S3 driver, which will store it into Amazon S3. So if we go to our S3 bucket, you can see that we don't have any pictures of Pikachu here. But if we go ahead and run it again, so Pikachu, submit, took a little bit longer, but that's because it uploaded to Amazon S3. Probably have to refresh here. And here we go. We have our picture of Pikachu in here. Boom. So that's some of the uploading support. Now, Masonite ships with these things called helper functions. They were more used in 2.0, but in 2.1 we sort of drew back on them a little bit. But one really cool feature, I think, personally, is we have this DD helper function. If you're coming from Laravel, you know exactly what this is. So what this does actually is takes this object, whatever it is, this actually returns a dictionary, and sort of spills it or dumps it out onto the screen. So you can sort of inspect it from there. So what I mean by this is that if I go here to this DD, it has a dictionary that's blank. But if I say hello is equal to test, right, this gets the input. So now we see here, and we can see all the sort of attributes attached to that. So to see that a little more in depth, we can actually dump this view object out, right? So this is the view object of returning templates. So let's go ahead and rerun that. And now you see that actually this view object is dumped out onto the screen. And you can see all the attributes of it. You can see the Jinja extensions that are attached to it, the dictionary attribute, the environments and the extensions. So it's just another way to debug. If you're not really sure what's going on, instead of doing 100 prints, you could do this DD, which actually dumps the object out onto the screen. So cool little feature. It's actually fairly new to Masonite, but I love it and I use it all the time. So moving on a little bit, for models, Django uses a data mapper style ORM, which if you're not familiar with different style of ORMs, a data mapper is basically, or at least how I explain it, is that you put attributes on your model in order to mimic the table. So if your table has a column, you have an attribute resembling that column onto your model. So the opposite of data mapper would be an active record style ORM, which sort of morphs into the table it's attached to when it retrieves records. So for example, if you look at this model, it actually looks very different than a Django model. So here's actually our model. So you notice we don't have any attributes really. We don't have a ID or a name or an email attribute because the attribute is sort of fetched and attached to the model as you call it from the table. I think it's way better than data mapper ORMs, and I think once you give it a try, you'll fall in love with it. So in addition to that, fetching records and interacting with data is actually much cleaner and sort of easier in my opinion. So for example, if we go to this model, remember that we created 50 users, right? So this is going to get Tiffany Olson. So we're going to find where the ID is 1, basically. Find this ID. So if we go ahead and go there, we dumped out the user object, and you see we have the attributes here. So name, email, password. Continuing on, instead of just getting 1 record, you might want to get the first record where the name is Julia Jennings. which I don't think we actually have one. That's Julia Jennings. We have Tiffany Olson. So let's get her. So if we dump here, we have Tiffany Olson, right? Which is basically the same thing that we had before, because she is the ID of 1. Now, continuing on again, we can get all records where the ID is greater than 40. So this should return us 10 records, right, between 40 and 50, because we only created 50 users. So here's the 10 records right here, right, between 40 and 50. And again, if we wanted to get all the records, we would just use the all method, which should return us a collection of 50 records. Now, the last thing I want to show is broadcasting or WebSocket support. A lot of applications, if made easy, would use WebSockets. So for example, if you want to send sort of like real-time notifications to a user's dashboard, it's really convenient to do, but a lot of frameworks make that challenging. They make you have to, set it up or bring in support or bring in libraries that are hard to configure. So Masonite makes that really simple. So if we go to actually our broadcast controller, you can see it's as simple as this, right? So we have our broadcast object that we have here. We want to resolve that from the container. So at one point before the server started, we loaded this broadcast object into the container. And now, since we put it in the container, we want to resolve it back out of the container and use it. So what we want to do is we want to broadcast on the channel CFE. I'm going to broadcast the string Masonite WebSocket message. So I believe, let's just check this route. This is our broadcast. So let's go here. And this says check console. Right? So we're going to inspect it, check the console, and we're going to duplicate this, which should now send the message here. If we refresh, you can see we're actually now sending WebSockets to our application. So you can actually see that updated from 2 to 3, since that took a while to load for some reason. So it's actually that simple to send WebSockets from your backend to your front end. So instead of this message, you might want to send the number of notifications that the user has, or you might want to show an alert box on the right side, telling them that a new action was performed. So since it's that simple, a lot of people are going to start using WebSockets in their applications. Now behind the scenes, it actually uses Pusher. So you just enter your Pusher credentials. We also have Ably support, which is a similar service to Pusher. And then in the future, we'll have local WebSocket support, which is actually something I've been working on the side. So before I go, if we actually just go to docs.masoniteproject.com, Masonite has some really extensive documentation. We have a philosophy of no pull request without documentation, so pretty much everything is documented here. Masonite has over 550 pages of documentation, so it has everything you need if you want to look up sessions or how to auto load, creating mail drivers, more about broadcasting or queues and jobs. All of that's right here, and it's actually pretty extensive. You can go down here, you can go to the tutorials if you want to learn how to create a blog using Masonite. That's a step-by-step. We also have a bunch of how-tos if you want to sort of explore more about how to do specific things with Masonite, so how to deploy it to Heroku, or further information of how to use RabbitMQ with Masonite. Depending on when you're watching this video, Masonite right now is in the 2.0 version, but in December of 2018, it will be released into version 2.1, which is using a lot of the features that you see here. So this application is a Masonite 2.1 application actually, but most of these features are in 2.0. If you also want further information, you can go to slack.masoniteproject.com and you can actually join the Slack channel from here. So go ahead and ask any questions that you have here or just talk with some of the maintainers and the community. All right, thanks a lot and hope to see you soon.